Hello friends, in this video I'm going to revise with you acids, bases and salts, and also two questions from organic chemistry. So the question is saying magnesium is a reactive metal. Question A, Roman numeral 1 is saying name the products formed when magnesium reacts with steam. So in this case here, when you talk of steam, it's more like we're talking about water. Okay, so when a reactive metal reacts with water, what is going to be formed is the metal oxide and also hydrogen gas. When a reactive metal reacts with steam or water, what is going to be produced here is the metal oxide and hydrogen gas. So in this case here, we are reacting magnesium to water or to steam. So what is going to be produced here is what? Magnesium oxide and hydrogen gas. Then as for Roman numeral 2 saying, write the equation for the reaction of magnesium with ethanoic acid. Okay, so write the equation for the reaction of magnesium with ethanoic acid. Okay, so when you're reacting a metal with an acid or to an acid, what is going to be produced here is what? A salt plus hydrogen. So in this case here, a salt which is going to be produced here is what? Magnesium ethanoate. Okay, magnesium ethanoate plus hydrogen gas. Okay, so when I react magnesium plus ethanoic acid, what is going to be produced here? It is the magnesium ethanoate plus hydrogen gas. Then as for B, magnesium chloride is a soluble salt. Describe how you can make pure dry crystals of magnesium chloride from magnesium carbonate. So in this case here, our start-up reagent, it is magnesium carbonate. So which means here we need to choose any soluble chloride which we are going to react with magnesium carbonate to have magnesium chloride. So let me choose sodium chloride. So I'm going to say mix magnesium carbonate with any soluble chloride. So in this case here, I'm going to use what? Sodium chloride. Then after mixing magnesium carbonate with sodium chloride or with any soluble chloride, I need to heat the mixture up to crystallization point. So I'm saying you need to heat. So I'm going to say heat the mixture up to crystallization point. Then after heating the mixture up to crystallization point, the crystals are going to be formed. So which means the next step, I need to wash the crystals. So in this case here, I'm washing the crystals of what? Magnesium chloride with distilled water or pure water. Then lastly, I need to dry the sample of magnesium chloride on a paper or a tile. Then as for C, it is saying the equation shows the reaction which occurs when magnesium carbonate is heated. So when a metal carbonate is heated, it is going to decompose to form a metal oxide plus carbon dioxide. So in this case here, magnesium is decomposing to form magnesium oxide plus carbon dioxide. Then the question is saying, state the name given to this type of chemical reaction. So this chemical reaction is called decomposition reaction. It is called decomposition reaction. Okay. Then as for D, it is saying a student compared the action of heat on 3 solid metal carbonates. She heated each carbonate using the apparatus shown below. In each case, she recorded the length of time taken for the limestone to turn nuclei. Okay. Then as for Roman numeral 1 is saying, state one factor that must be kept constant if the speeds of reaction are to be compared in a fairly, or let me say fair way. 1 mark. So which means on this part here, the temperature should remain constant, okay, or the temperature should be the same. Then as for Roman number 2 is saying, the time taken for the lime water to turn nuclei for each metal carbonate is shown in the table. So we're having metal carbonate, then time taken for the lime water to turn nuclei per second. So the first one is copper carbonate, having the time of 10 seconds, followed by magnesium carbonate, having the time of 40 seconds. Then as for zinc carbonate, having the time of 24 seconds. So in this case here, for us to answer this one here, the question is saying, first, see, the question is saying, describe and explain these results in terms of the reactivity of the metals. So let me try to display, okay? So let me just display the reactivity series of metals. So the first one is it is potassium, followed by magnesium, followed by calcium, followed by the first one is potassium, followed by sodium, then calcium, followed by magnesium, followed by aluminium, followed by carbon, then the next one is zinc, iron, tin, lead, hydrogen, carbon, silver, and gold. Now, to remember all these reactive metals on the reactivity series, okay, or to remember the metals on the reactivity series, I'm going to give you a mnemonic which goes like this. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. So in this case here, please is representing the what? Potassium. Then stop is representing sodium. Calling is representing what? Calcium, and so on. Now, how it is here is like this. The more a reactive metal is, the more a metal becomes difficult to decompose for metal carbonates, okay? So for metal carbonates, the more the metal, the reactive is, the difficult it becomes to decompose. So in this case here, magnesium carbonate or magnesium itself, it is very reactive, okay? Magnesium itself is very reactive. So you are going to find that since here we are having magnesium, so magnesium is a reactive one, followed by zinc, then the last one is what? Copper, according to the table here. So I'm going to say the more the reactive the metal is, the difficult it becomes to decompose for metal carbonates, okay? So the more the reactive a metal carbonate is, the more it becomes difficult to decompose. Whereas the less the reactive the metal is, the faster it decomposes, okay? The faster it becomes more to decompose. That is for what? Metal carbonates. Okay, so let's move on to the next one. So it is saying ethanol can be made by, ethanol can be made both by fermentation and by the addition of steam to ethene. Then as for A, Roman numeral 1 is saying, name the organic compound required for fermentation. So here I'm going to say maize or cassava. If you want, you can say hydrogen and carbon. Okay, hydrogen and carbon. Or just say maize or cassava. Then as for Roman numeral 2 is saying State the conditions under which fermentation most readily takes place. State the conditions under which fermentation most readily takes place. So the first one I'm going to say, the temperature of about 37 degrees Celsius. The temperature of about 37 degrees Celsius. Then, the last one, the presence of an organism called yeast, or the organism yeast should be present. So those are the conditions. Then apart from that one, you can also talk of anaerobic respiration, okay? That one is the condition. Oxygen should not be present there, which means it's anaerobically. Okay. Then as for B, write an equation for the reaction between steam and ethene. So ethene is falling under alkenes. Okay. So when you talk of steam is more like water. So I'm reacting water plus ethene. Then what is going to be formed here is what? Ethanol. What is going to be formed here is what? Ethanol. So water plus or steam plus ethene. What is going to be produced here is what? Ethanol. Okay? Ethanol. Then as for C, ethanol reacts with ethanoic acid. Reacts with what? Ethanoic acid. Then the question, which is Roman numeral 1, is saying, name the compound which is having C, H3, COO, C2, H5. So in this case here, this one here is having what? 2 oxygens and 4 carbon atoms. So which means this one is going to be what? Butanoic acid. This one is going to be what? Butanoic acid. Because acids, they have the functional group of Cu, which is COOH. Okay. Then as for Roman numeral is saying, what name is given? What name is given to this type of chemical reaction? So when an acid reacts with an alcohol, the reaction is what? Esterification. The reaction is called, or the chemical reaction is called what? Esterification. Then as for D, Roman numeral is saying, name the third member of the alcohol homologous series. So in this case here, we have ethanol. Now the third one, it is called what? Propanol. Okay? The third one is called what? Propanol. Then the last one, which is Roman number 2, is saying, draw the structural formula of this compound, showing all atoms and bonds. So which means here, propanol, it has 3 carbon atoms. So it is C, a bond and another C, and also a bond, then the last C. And then also you distribute the what? The hydrogen atoms. And also don't forget to put what? The functional unit of alcohols, which is hydroxide. And remember, carbon can only form about 4 bonds, okay? Yes. So let's try to answer the last one. The last one is saying the alkanes are a homologous series of saturated hydrocarbons. Question A, Roman numeral is saying, write the general formula for the alkane homologous series. So the general formula, it is CN, it is CN, H2N plus 2. CN, H2N plus 2. CN, H2N plus 2, where N is representing the number of carbon atoms. Okay. Then the next one is saying each member of a particular homologous series has the same general formula. Give one other characteristic of a homologous series. Okay, so what I'm going to say here, I'm going to say each member differs from CnH2n. Each member differs from CnH2n. So in this case here, you're going to find that when you talk of ethane it has what? 2 carbon atoms. But as for propane, it has what? 3 carbon atoms. So what differentiates these? It is CnH2n. Okay? So they differ from CnH2n. Okay. Then as for B, what is the meaning of the term saturated? So the meaning of the term saturated, it is more like you are talking about single bond. Okay. So when you say alkanes are saturated hydrocarbons, which means they contain a single bond. Okay. So I'm going to say the term saturated means single bond. Okay. Then as for C, construct the equation for the complete combustion of pentane. Okay. The complete combustion of what? Pentane. So when pentane undergoes complete combustion, what is going to be produced is what? Carbon dioxide plus what? Water. Okay. Carbon dioxide plus water. So I'm reacting pentane plus oxygen. Pentane plus what? Oxygen. So what is going to be produced here is what? Carbon dioxide plus water. So when you talk of incomplete combustion, when you talk of what? Incomplete combustion, the products are going to be what? Carbon monoxide plus what? Water. Okay. Then as for D, it is saying, draw the structure of a blanched alkane with the formula C5H12. Show all the atoms and all the bonds. So in this case here, let me display the answer. It is C, or let me just say C with a bond, another C with a bond, another C. So in this case here, we are having how many carbon atoms? They are about 5. Then all the bonds need to be occupied by what? Hydrogen atoms. Okay. So let's move on to the last one. Okay. The last one, it is saying chlorine reacts with pentane. Chlorine reacts with what? Pentane. Chlorine is what? It's falling under halogens. Okay. It is falling under what? Halogens, which are group 7. So Roman numeral is saying what name is given to this type of chemical reaction? It is called halogenation. Halogenation, okay? It is called halogenation. Then as for Roman numeral 2 is saying what essential condition is needed for chlorine to react with pentane? So I'm going to say UV, which is what? The ultraviolet. This of the ultraviolet here, it is to break down the what? The bond for the reaction. Since they are saturated what? Hydrocarbons, which means for them to undergo the reaction, the bond should be broken down, or one bond should be broken down to allow the reaction of chlorine. Okay? Yes, so it is UV or a spark. That's all. Thanks for watching.